Greetings, fortifiers of data. This is Michael Hudak giving to you a video of a panel I was recently on at the IRIS Electronic Technology Expo and Symposium. I was brought on thanks to Greg Orlov's IOT World, and I was joined by Neil Singh of Team Neo and Scott Wolf of Macentry. It covers some ways the industrial Internet of Things is trucking along, the impacts that technology is going to have on manufacturing, and a little bit of cybersecurity stories. So, hope you enjoy it.
So how's lunch? Great. Oh, I heard great. That's outstanding. So as Mark mentioned, on behalf of the panel, I want to thank you all for inviting us here today to provide what hopefully is an interactive dialogue and have a little bit of what I would call a fireside chat about the industrial side of IoT. I'm from IoT World, as Mark mentioned. Gave you a title, my background, so I'm not going to delve into that anymore. But is anyone familiar with IoT World, just out of the crew here? All right, we got some good followers out here. So maybe just a quick overview for the folks that aren't familiar. We are a digital publication. We're based here in Cleveland, Ohio. And we cover the economic and the technological implications of the transformation that is taking place as the industrial Internet of Things, or IIoT, proliferates throughout the enterprise. So it's a big mouthful for we're tracking what's going on from an innovation standpoint and technology standpoint. And we'll touch on in a moment what exactly the industrial side of IIoT means. I think the players in this room have probably got a pretty good finger on the pulse of what that is. We combine journalistic coverage with data analysis, and we're ideally looking for the stories that are going on in business as this stuff starts to extrapolate. So our mission is to help connect the smarts. So ideally what we try to do as an organization is, how do you take the technology that you're pushing out into the marketplace, the innovations, whether it's sensors, whether it's meters, whether it's operational things, or even products and services, how do you get that in front of the people that need it? So how do you put that in front of the decision makers globally, whether they're in the C-suite or they're out in the field in the lines that are trying to drive this technology forward? So we have over 300 contributing authors globally. We're on 6 of the 7 continents, and I always make the joke that I'm pushing for somebody on a field station in Antarctica so we can claim all 7. I have over 170,000 followers across social media. So we've done a fairly good job of penetrating the marketplace, and I'll stop boring with statistics, I promise, but over 90% of those folks are at the senior executive to C-suite level. So there's a pretty good demographic if you want to get your stuff in front of people that are going to have decision-making power. Let's have a chat. So without further ado then, the agenda for today's session, as I said, we're going to keep it fairly loose. I'm going to invite each of the different panelists up here. I'll give a brief bio on each of them so you know who we're talking with. They're going to give you an overview from their perspective of their company, some of their past history, and maybe some case examples of things that they've experienced on the industrial side of IoT to share with you. So once we move through those 3 presentations, and we'll keep it short, each one of them is no longer than 86 slides, so we'll be out of here by 6 o'clock. Oh crap, I heard it back there. 5 slides max, guys, so this isn't a PowerPoint. We want to get into a dialogue. So the key on this is I'm going to wander around this room with a microphone after we do our little presentations here and open up the floor to you folks. If you've got questions, you've got thoughts, you want to share a success story, you want to share an agony of defeat story or a lesson learned, by all means, throw it out there. So that's essentially what's going to happen for the balance of the 45 minutes or so that we've got remaining here. So our first panelist is Neil Singh. And Neil is the Chief Technology Officer. No, what are you, Neil? You're Director of Technology for Team Neo.
But I like the title.
You like the title? I'll pass that along. So I'm going to invite each of the panelists up to take a seat as I read the bio. Neil engages with companies to help them explore growth opportunities with emerging technology adoption that will impact both the information technology, or the IT piece, as well as the operational technology, the OT sides of an organization. And he touches on the Internet of Things, artificial intelligence, blockchain, and a whole gamut of other different topics. So that's Neil's role with Team Neo. Our second presenter is Scott Wolf. Scott is the President and COO of Macentry. He's been involved in improving process and applying technology to obtain and maintain business benefit for over 20 years. Scott's held various executive roles that have helped many of the region's largest companies define their enterprise operation system strategies. He's also redesigned business processes and applied best practices for the financial, sales, marketing, customer service, and supply chain functions. He's also an alumnus of and adjunct professor at Case Western Reserve University's Weatherhead School of Management in their MBA program. So welcome, Scott. Our final speaker today is Michael Hudak. And he's a tech author. He's based here in Cleveland as well. He possesses a wealth of knowledge to share on technology with over a decade of experience in all things tech, from blockchain to IoT to general routing and switching and cloud implementation. Today, Michael works with Blue Bridge Networks, world-class SSAE 16 SOC, third-party audited and HIPAA high-tech assurance data center and PCI best practice company offering secure and compliant data center services, cloud computing, and managed services and IT services. And
we like acronyms.
Like acronyms, it's a mouthful. He also runs Fortify Your Data, which is a tech podcast covering emerging technologies. And his book, also titled Fortify Your Data, is available in bookstores around the world. So, there's the panel. So these are the people that you're going to have the opportunity to interact with here and pick the brains of. So I'm going to invite Neil up to give you a short presentation on Team Neil.
Can I stay seated for this?
You can stay right where you're at. That makes you happy.
Cool. That does make me happy. Hey, first of all, thank you all for attending. I appreciate being here, and I appreciate IOT World for organizing this. Shall we go straight into the deck? So Team NEO is basically an economic development organization in Northeast Ohio. We cover all 18 counties of Northeast Ohio, and we facilitate financial and non-financial incentives with Jobs Ohio as the state partner. So that's what we do for business growth and development. On the other side of the coin, we also facilitate industry IoT initiatives and smart manufacturing initiatives with our cluster events. We have about 4 to 5 events every year, and each of them attract about 200 to 300 manufacturers in the region. We are trying to grow that cluster. Is it auto running? There we go. So just quickly, in terms of how I see emerging technology and from a number of sort of quantitative and qualitative research studies that we've conducted, this is sort of your puzzle or roadmap of different technologies that are part of IoT and industry IoT respectively. As you can see, and I like this representation because a lot of the time what we tend to see in conversations is that technology is siloed. So, somebody's doing augmented reality on one end, somebody's doing blockchain on the other end, no one's talking to each other, they're all separate activities. I don't see it as a separate activity. I see all of them, sort of playing a role holistically in terms of emerging technology development and companies sort of being able to understand that and then see how that applies to their organization. All right, next slide now. So, to boil it down in its simplest form, that puzzle translates to this for business. There are 4 key aspects to Industry 4 and IoT innovation, and these are some of the elements. I'm not going to read them all out, you can clearly see it there. For manufacturers, it generally sort of leans on how do we develop smart manufacturing? Where do we start? And what is the goal? How do we start with something small and scale? And what are the tools and technologies available to collect that data, analyze that data, and obviously create some value from that data in our business? Next slide.
Here, Neil, take the power. There's no reason for us to,
thank you.
Yeah.
Which one is it? Okay, thank you. So
I'm willing to do it.
this is sort of more of an ecosystem of how all that fits together. This was actually pinched off a Deloitte slide or something, but I thought it was a nice representation of sort of the business challenge and what we're trying to solve here. Smart production systems for manufacturers and engineers. That's the first one, obviously, and that goes into the value chain and supply chain, how you do business, who you do it with, and what technologies are they sort of working with, and how you're adapting to that as a business. And then you go into sort of the scaling part of it, which is the last one, acceleration through exponential technologies. This is really a case of finding the best type of technologies that work for your business and your supply chain, and making them all work together to create some real business value and return on investment. So the broken down, this is what I think some of the opportunities in Northeast Ohio look like for a lot of our businesses, especially for smart manufacturing and engineering. You know, some of the examples or use cases, for example, remote predictive and prescriptive maintenance. This is something that, you know, if you're running a manufacturing plant or smart manufacturing plant, you've got a lot of machinery, the ability to collect data and figure out when that machinery might fail or when you might need to replace parts or do a number of things like that. It's vital to business. It's vital to keep your operations going. So that's just one use case, one example of how, you know, sensors, smart devices, and technology can actually help your operational efficiency. Next level automation, that's pretty straightforward to understand. I think automation is the buzzword in manufacturing these days. Doesn't matter where you go, whether you're an aerospace manufacturer or an automotive or anything in between. You're looking more at robotics, you're looking more at technologies that help you work faster, better, and more optimized. Digital performance and quality management. This really looks at best practice, I think. And it's important to consider in your day-to-day business operations and your supply chain what best practices are in use and why you should obviously be creating processes in your company to adopt these best practices. The end result of that is it increases your market share. You know, if you're using industry best practice, then more people will do business with you. Process optimization, operational efficiency. We kind of already covered this in the first example. You know, being able to maintain your technology and your machinery and hardware better using predictive and prescriptive tools will lead to operational efficiency in your smart manufacturing operations. And then transforming tribal knowledge to digital training. Now this one, I personally think is very important because it's not a technology one, it's a culture one. You have a lot of smart manufacturing that sort of goes out there and says, well, you need to adopt to technology and adapt technology into your business. But the challenges that our companies are facing in Northeast Ohio and across the world, in fact, is that you've got engineers and, you know, workers in the plant that have been there for 20, 30 years, and they know the ins and outs of their operation. They know how their business works. You can't just walk in there and say, use this iPad, you know, to do your job. They're not going to buy it because they know better than anyone else how their business works. So at the end of the day, the ability to encourage or champion the professionals in the industry that have been in the industry for a long time to use the technology, adopt the technology, comes from, first of all, having them contribute their knowledge into what's needed in the business. And this is important. You know, if they come forward and say, well, having a smart sensor on this device would help us in this way, then you've got some buy-in from smart manufacturing. The other thing also that comes into sort of transforming tribal knowledge into digital training is things like digital twins. So what can you do once you've gained the knowledge from experienced workers in manufacturing? How do you transform that into a technology process? How do you create it into something that the future workforce that's coming into your company can leverage? So that's, I think that's a very important one. Sorry if I rambled on a bit. And this is just a summary of all of that. You know, end user adoption is key. So whatever sort of you're doing in terms of technology, whatever you're doing in terms of manufacturing or engineering, this is a big one. You've got to get users to buy in. You've got to get people to adopt what you're sort of selling. And then the end result of that is that you're collecting data all the time. How do you try and transform that into value? And that's sort of how I summarize that. So thank you for your time. Go on to the next.
I'm going to stand up a little bit. So we're going to tell you a little bit about MetaCentury, why we matter in IoT. And I'm going to tell you a little story about how long I've been in IoT. So just as a quick conversation, right? Like, how long has it been since we've been talking about IoT? Right? Quick raise of hands. Do we think it's been 5 years that we've heard the term IoT? Has it been 10 years or longer?
It's been a lifetime.
Right? I don't remember hearing it 10 years ago that much. Right? It started happening as far as a term, as far as a concept. It feels like only 5 years, right? It's been 5 years since I got a thermostat in my office, and when I looked up to get a wireless connection on my device, I could see the thermostat on the wall. I was like, oh, that must be that IoT thing they're talking about. So I've been doing IoT for longer than the I has been in there. What do you mean? So the Internet of Things, I've been doing IoT before the Internet. And I'm guessing all of you have too, right? So, 1990, I'm a kid at Accenture at LTD Steel in the Mill, and I'm in the IT organization. And they come to me and say, hey, we've got a non-union position that sits outside of a scale, and the scale brings in ore, and we weigh the truck on the way in, and then we weigh the truck on the way out, and that's how we figure out how much we're going to pay the supplier, because that was the load that came in or the load that they took out. Scott, can you figure out a way, because this is a non-union position, we'd like to kind of take on the position, can we get some data from that scale and essentially make the process more efficient by removing the person that stands there and writes in the book the weight of that truck on the way in and the weight of that truck on the way out. So it's 91, right? So I gotta think through it, right? I got a PC, an old IBM PS2 probably, and I got a modem. I gotta go talk to the scale guys to figure out, hey, can I even interface that scale with this PC to get that kind of data? And the thing is, in the middle of the mill, there's no network out there. Back in 91, there's no network out in the middle of the mill. There's no internet. There's certainly no wireless. So we go get a modem, run a phone line, and I start putting this whole thing together. And then, okay, I need a PC on the back end to receive this call. And I'm putting together the system, and it starts to get pretty expensive. And all I knew is I'm a kid, I'm a consultant, I got to put together this solution. And real quickly, we realized, all right, so what if the PC breaks? What if the modem doesn't answer? All this other stuff. Now I need a company to come and support the PC, right? So we start adding up all the costs, and then start adding up all the savings. And that savings part wasn't initially shared with me, right? Like, hey, we're going to take out this, the scale worker. So we're going to save about $40,000 a year because there's 3 shifts and we pay them X, right? So I'm starting to craft this solution, and it's really just an Internet of Things kind of solution. So it really hasn't changed too much when you think of what we're doing today, right? It's either there's a business case that better get identified first, or the poor guy, who was me at the time, doesn't know what are the frameworks that he's working within, how much money can we save? Or if it's not a process optimization, is it a new business endeavor? Is this thing gonna get us revenue? How much revenue do we project? So fast forward 20x years, right? So we built MetaCentry with kind of the intention to help solve the problem for the engineering teams, or for the poor guy that's been handed this problem statement that, like most people, they would say, absolutely, I can solve it, right? But when you think about it, the same things that were necessary then are still necessary now. So where MetaCentry plays is, we have a business strategy group that will come in and work with executives to figure out what is is this an efficiency play? How much of an efficiency play? Or is this a revenue? Is it a new channel? How much new revenue are we thinking we can get? And we define it, and we get the executives to commit, hey, this is going to be a $10 million opportunity if we can capture it in 5 years. So now we've got some money that we can work within, right? And then we, build the business case, which tells us what our investment can be, and then we'll try to model it out. And then, there's usually a business process. Now that we've identified this process, we better map that thing out. What's the current state? What are all the people? What are all the pieces? What are all the costs? What are all the possible opportunities? Map the business case, map the business process, and then obviously there's an engineering solution, right? So where's the structure of the data is usually the question that we have to figure out, right? We can get the data from the shop floor, right? Either add some sort of device that collects it, or there's something embedded in the machine, right? There's always a how and why, but that's the what, and usually everything can be interfaced to these days, as it was possible in 1991. There's a way to get the data. Where are you going to put the data? And in this case, we're not just dealing with one device, we're dealing with hundreds and hundreds of thousands of devices. So the data's got to be in some place that makes sense, because that data set gets huge very quickly. So this development architecture team is more about data management, more about data structures, and some engineers, you don't want to worry about, what does the data model look like? Right? You're just tasked with, I got to get the information out of this piece of equipment and into the cloud, and that's all I'll, sign up for. Some people are, more interested in what the data structure looks like, but our guys are definitely, they're absolutely only interested in the data structure so that it's efficient, so that it can actually solve your problem. And then there's a cloud operations team that is more about which cloud makes sense for this, or do all the clouds make sense for this, right? And there are so many. You can have a private cloud, you can have AWS, you can have Azure, you can have Google Cloud, Oracle can be your cloud provider. There are so many, and you can have a solution with absolutely every cloud provider involved, depending on what are the pieces of the solution, right? Is this thing going back into your ERP? Well, maybe the Oracle Cloud makes sense if Oracle's your ERP. Is the SAP your back end? Then maybe SAP Cloud makes sense. Is it a custom back end? Well, then maybe that makes sense, right? To develop something else, maybe on AWS or on the Google Cloud. So our organization is kind of still, it really, and one more slide, I swear. And I'm not going to talk all about these, but when we break down any IoT solution, it has all these components, right? The first layer has to be, just like I needed when I first was presented this problem, what are we saving? What is my business case here, right? And then what is the process? That's the second layer. What's the data collection strategy? Like, is the thing we need, does it already have it built in? And then if there's 100,000 of them in the same floor, how am I going to aggregate that so that I'm not letting everything talk directly? And then the cloud transport, again, where are we putting it and how does it get there? And then, the data management layer, the application logic layer, who is this helping? Right? What is the logic? How do we present that data to them? And how do we let them interact with that data? Or does it integrate into an enterprise system? So this is kind of where each of the practices of Metacentric fit into those layers. But I'd say the one that we're having the most conversation with today is right here, right on the strategy side, because most people are being told to do something, and it's usually starting with a question is, hey, can we do this? And the answer is always yes. We can do it. Like, you can do it as the engineer. We could do it as the systems integrators. But why are we doing it? And what is the business case? So if you're going to engage with Metacentric, we can help build the overall solution. You're the engineers in the shop floor, you know what sensors you need, you know what sensors you have. We can help you, with our partners as well. But we're going to spend a lot of time here at the C-level with your executives to try to figure out what is a real business case, so you don't go design something that doesn't make sense for the organization. But that's what Metacentric is. I'm going to turn it over to Michael.
Look at that picture of me with hair. Wow. I really liked, I have a little bit of contempt for everyone that's over 30 and has good hairline.
I'm 60.
A lot of contempt. Yeah, I actually also appreciated Scott's conversation on the cloud, except the fact that he didn't mention Blue Bridge's cloud. And I would say that that's always the correct option, mostly because that, in a roundabout way, helps me make my house payment. All right, I'm also not a PowerPoint guy. I was told I have 5 minutes, and so I made literally 2 actual slides, which is just a bunch of jumbled up pictures and a couple bullet points. So I have 2 functionalities in life. One is cybersecurity and one is data storage. I have, for the majority of my life, really been hinging on cybersecurity, but people also are more willing to spend money on data storage. So you do what you need to do. As far as IoT goes, I've worked on several interesting projects that I would like to share with you. The most interesting one is for a power plant about 2.5 years ago now. They did not use those thermometers, but that's the only picture of a smart thermometer I could find on Google Image at 2 a.m. last night. Basically, it was a power plant that had thermometers. The thermometers didn't go into anything that was actually generating like any kind of I don't know, nuclear chemicals. It was just the office thermometers. But they were smart, and when I say they're smart, they connected to the Wi-Fi. And when they connected to the Wi-Fi, they connected to an app. And when they connected to an app, they connected to somebody's phone. And when that person goes into a Panera, I can use, is this a pointer? Whatever. I can use this Wi-Fi pineapple. This looks like one of these buttons should be a pointer, but apparently not.
Do you want one?
No, it's thank you, I appreciate it, but the time has passed. I no longer, yeah, point to the pineapple up there. So, I don't sell the other one, the thing that isn't a thermometer. There you go, yeah! Alright, so I don't sell those, but you can buy them on the internet for $100. It is effectively a router, and what it can do is it can intercept traffic. You can create captive portals. You can go into a Starbucks, this isn't legal, but you can go to a Starbucks and you can set up a captive portal that looks identical. You can clone it. You can get that portal on GitHub for free, upload it, people log into the Wi-Fi. They're still accessing Starbucks internet, but you are recording all of their passwords and keystrokes and such. One of those keystrokes in this situation would be the password to the thermometers, which in this situation was the same password this guy used for his Windows Active Directory domain, which kind of got us into the rest of the power plant, which is cool. And the point of that is any device that you guys are putting in, either whether it's your house or your business, whether it's a fridge, which you can also get into if you sit outside your friend's house with one of these powered up. You have to get a little creative with how you're going to power it, but with enough batteries you can sit out there for a while and brute force somebody's fridge and then steal their family photos. Which again is a bargain considering this is only $100. They have a stronger one, but you really only need that. I rambled a little bit, but the point of that is when you're installing these IoT devices and they're connecting, you have to understand what they're connecting to and what visibility to the network those apps have. In my experience, the vast majority of people that are pushing out these products are pushing them out without thinking about the cybersecurity ramifications. And so they have an app that has a great user experience, but it really doesn't have anything to safeguard people from kind of worming their way into your emails. And the other unfortunate thing, and this is just more of a cybersecurity thing than an IoT thing, when you're looking at the way people keep their passwords, how long they keep their passwords, using the same password for every single thing, whether it's their Facebook or their email at work, it's pretty easy to get into things. So that's basically what I do during the day. I also wrote a book that I just tried to jam. You can't read it real well, but every buzzword I could think of, so cybersecurity, Internet of Things, blockchain, and artificial intelligence. It really just pertains to what cybersecurity does pertaining to those devices. In this situation, the Internet of Things. I've gotten into all sorts of, like I said, fridges. I've gotten into people through people's cars. Just the cars have built-in Wi-Fi. If you have like a Tesla, you can actually get in there, and then you can just GPS them around. I want a Tesla still, though. You can GPS me. Those things are sweet. But I just really don't want to drive anymore. But the other side of my world is storage. So I also work for Blue Ridge Networks. They initially brought me on to do cybersecurity, but then they found out that more people will pay to store things than they will to secure things. So we developed a cloud. So we started as a data center in 2004. The cloud probably rolled around in 2009. We're an augmentation of other clouds as well. So if you want to be in Azure, we have an Azure stack. We manage AWS. This isn't really a sales pitch for that. What this is a explanation of when you're building a cloud and you're building some kind of smart city, you're trying to have your backups in as many places as you want. Is that a hand raise? No? Okay. Never mind. But what we do that's a little different with our cloud, which we recommend you do with any instance that you have, is put some analytics on the data that you're storing. So pertaining to these IoT devices that are just pumping up data, whether it could be camera footage, it could just be sensors. Like a good example is, so for the art museum, that art lens exhibit, when you walk in, there's sensors everywhere that we put in. And so one of the functions of the sensors are you can control the walls with hand gestures, and you can walk through an interactive experience. And if you haven't been there, it's free, so you should go there. Also, I had a hand in it, so that's pretty cool, right? When you walk through it, it's recording every single hand gesture that you have, which seems like dumb data, but you need some analytics to actually store that, because if you get hacked and they corrupt one of those pieces of data or one of those files, you just have to start over. And I've seen that many times when people get ransomed, as far as like where storage is concerned. They get ransomed, but then they can't even figure out where the problem was, and they backed up the problem for X amount of years, and even if you go back 1 year, it's how much business have you lost at that point. Most people have backup strategies and clearly defined RTO and RPO schedules, but they don't actually test what would happen if a very small part of that network or environment was deliberately compromised. And that's kind of the state of the Internet of Things security and storage. There's my contact info, another picture of me with hair, the same picture of me with hair, and then 2 logos that I typically represent. That's what I got. Here you go, Greg.